Hi, now in this video what I want to do is talk to you about tree diagrams. They're very useful when it comes to working with probability, and you might also use them if you're studying permutations and combinations. Now what I've got here are three examples which should show you various tree diagrams, and hopefully you'll be able to model other examples that you do on these type of diagrams. So to start off, we've got this arrow on this spinner here, and it's spun twice and the number of wins are recorded. And what we're going to do is draw a tree diagram showing the possible outcomes. Now by outcomes we mean what can happen when you spin the spinner. We'll either get a win or we'll lose, depends on which sector this arrow lands in. So we have two outcomes, you either win or you lose. So we can show that by drawing two branches like this, okay? And one will denote a win and the other one will denote losing. I'm going to write this in as W for win, and instead of writing say L for losing, I'm going to use another notation which is W with a line across the top saying not winning, but it's up to you. So these are the two outcomes we get with the first spin. Now suppose we won on that first spin, then when we go to spin this again, we'll either win again or we'll lose, not win in other words. So there'll be two outcomes off of this branch, and we can put them in like this, a win or not a win. And it's always a good idea to keep your letters here in the same order that you've got here. Now suppose on the first time you didn't win. You spin the spinner again and you've got two outcomes. You'll either win or you'll not win. And we can do that by showing these two branches here. And again, I've kept the order the same. And so this would be a typical tree diagram for something like this. Now in this next example, I've got this box of sweets. It contains one red sweet, 4 blue sweets, and 3 green sweets. And 2 sweets are going to be taken from the box, one after the other, without replacement. And I want to draw a tree diagram to show the possible outcomes that we can get. So when we go to take the first sweet, what are the outcomes? What are we able to get? Well, we'll either get a red sweet or a blue sweet or a green sweet. So there's going to be 3 outcomes, and we can show that like this, 3 branches with a red sweet, a blue sweet and a green sweet. Obviously you don't need to write them in their various colours. I've just done that for the effect. Now this is where it gets interesting and different, because if we took out a red sweet first of all, that red sweet there has gone. So when it comes to taking out the second sweet, we've only got 2 outcomes. We'll either get a blue sweet or a green sweet. The red sweet has gone. We didn't replace it. So if we show those outcomes there off the branch with the red sweet, we've got the choice that we'll either get a blue sweet or a green sweet. Now if we took the blue sweet first of all, then there's still going to be a red sweet in the box, some blue sweets and some green sweets. So we've got 3 different outcomes there, and we can show that by putting 3 branches here, red, blue or green. And similarly, if we took a green sweet first of all, then we're still going to have the red sweet in the box, all the blue sweets and some other green sweets. So we're still going to have 3 choices, 3 outcomes. And so this would be a typical tree diagram showing all the possible outcomes then for taking the sweets from this box. Now for this last one, I picked this because this is a very interesting one. we've got a die is thrown at most 3 times, and if a 6 is scored, the game stops. And we've got to draw a tree diagram to show the possible outcomes for this one. So when you throw the die, first of all, what can happen? You can either get a 1, 2, 3, 4, 5 or 6. So we've got 6 outcomes, which we could show something like this. Now if you throw the 6 first of all, then the game stops. But if you were to throw a 5, you're going to have another go. And what can happen? Well, there can be 6 outcomes here. And if I put those in, this is going to be quite hard. 1, 2, 3, 4, 5, 6. 6 outcomes there. You'd either get a 6 again, a 5, a 4, oh gosh, not much room here to write this in, is there? 3, 2 or 1. Okay, so you're just going to have to imagine that you can see that. And it doesn't stop there, because I could have thrown a 4 first of all, and then I've got to try and squeeze in 6 more options here. 6, 5, 4, 3, 2, 1. And it's going to be the same if we were to throw a 3. I'm clearly running out of room here. So I'm just going to put and so on, okay? There, and so on. And if I were to throw a 6 after throwing a 5 here, then the game would stop. And if I threw a 5 on the second go, then I've got to throw the die again, and there could be 6 options here, 6 outcomes. I'm not even going to bother trying to write them all in there. If I threw a 4, there's going to be 6 outcomes, and so on. This tree diagram's going to be really hard to draw. Really, I should have a lot more space. So it's hard to draw. So can we come up with something better? Well, yeah, we can. It's better to do it like this. Certainly when it comes to working with probabilities, as you'll see later on. We can either throw a 6 on the first throw or not a 6. Okay, that will be the 1, 2, 3, 4, 5. So it's greatly simplified this first section here. And if I threw a 6 first of all, well, I just stop throwing the die, okay? But if I don't throw a 6, then I've got to throw it again. And what could I get? 2 outcomes. I either get a 6 or not a 6. And again, if I threw a 6 on the second go, I stop. But if I don't throw a 6 on the second go, then I have another go. And I would have 2 outcomes again, either a 6 or not a 6. So this tree diagram would be a lot easier to draw. So I hope I've given you some idea now of what a tree diagram is and how we can go about drawing them. Okay, thank you for listening, and hopefully you'll come back and look at other videos on my website if you need support. Don't forget, the site is totally free. It just relies on your support to keep it going.